After 100 years of nourishing the intellect of science, the revolutionary construction of the Information and Learning Center leaps over boundaries of traditional library concepts and pioneers in the futuristic, ultra-modern library system provided for the community of scholars at the Faculty of Science, University of Colombo. The libraries that we are familiar with are mainly defined by transactional services, simply lending and returning books. But as the dynamics of the library systems has changed, the modern libraries are shifting more towards a relational side, creating more value to its users. Let me give you a short tour around our mind-blowing construction. The main building consists of 6 floors. The first floor is more like the principal floor of the complex, which includes the circulation desk, reference section, reading area, staff reading zone, leisure reading corner, and the thesis collection library office, as well as the library service center. The Learning Center here promotes the self-service concept, allowing you to do your work independently with the Learning Center. Advancing from the former library system, the Learning Center is also equipped with an RFID security system which improves the flexibility within the complex. Moreover, the self-check machine also allows the users to manage their books by themselves. The third floor is more like a collaborative study zone, which provides the perfect platform for projects, group discussions, workshops, and other learner-based activities. A library skill lab is also incorporated in this floor, which supports user-preferred arrangements and is equipped with e-boards and other technological equipment to provide a comfortable learning space. Moreover, the floor also has a library studio which is equipped with LED screens, video conferencing facilities, lecture recording facilities, and many more to support the efficient learning system. The fourth floor is an interactive study zone which includes a e-resource center alongside a self-study carrel. The e-resource center consists of computers, projectors, and e-boards. The ground floor provides an open study area for the users with a seating capacity of around 80 and a photocopy center. The newest addition to the library system is the exclusive coffee shop, so you've got the perks of relaxing and enjoy a warm cup of coffee as you work in the study area. The fifth floor is an adjustable space, which is more precisely a multi-purpose floor with 300 seating capacity. Finally, the sixth floor is the auditorium with 275 seating capacity and all the modern equipment for an immersive multimedia experience. Apart from the aforementioned, the Learning Center contains a free 24-hour Wi-Fi connection, laptop charging facilities, and many more to promote a pleasant and relaxed learning experience. With all these transformations, the students have been given an amazing opportunity to experience the modern academic systems in their learning period at the Faculty of Science, University of Colombo. Thank you for joining us on the tour.
සුබ සන්ධ්‍යාවක්. විද්‍යා විෂය හදාරන කොයි කාටත් ගණිතය කියන්නේ අතිශයින් වැදගත් විෂය පැතිකඩක්. Department of Mathematics. කොළඹ විශ්වවිද්‍යාලීය විද්‍යාපීඨයේ ගණිත දෙපාර්තමේන්තුව නවක ඔබට හඳුන්වා දෙන්නටයි දැන් සූදානම් වෙන්නේ. ඒ වෙනුවෙන් මේ මොහොතේදී මම ගෞරවයෙන් ආරාධනා කර සිටින්නේ මහාචාර්ය සංජීව පෙරේරා මැතිතුමන්ට.
Good evening, all of you. Our next session will be conducted by Department of Mathematics. So I would like to invite the head of the department, Professor Sanjeev Pereira, to address the gathering.
So, good afternoon. First of all, on behalf of the Department of Mathematics, I would like to welcome all of you into the Faculty of Science. So this year is a very historical year for us. So the Faculty of Science is celebrating 100 years excellence. So I believe like that now in this historical connection, you as a student community, also the batch, so perhaps like that now your batch is so much important. So then let me again welcome to on behalf of the Department of Mathematics. So actually my idea is like that to give a brief introduction of the department and also introduce my team, and as well as some of the programs which we are offering, and as well as some kind of like a subject, right? Give like a brief idea, right? And I believe like that then if you have any questions or any inquiries, please, we are sharing the WhatsApp number, so you can actually send any inquiries to that particular WhatsApp number, right? So this is actually the vision and the mission of the Department of Mathematics. As you see like that, now our vision is to be the department that is recognized nationally and internationally as a center of excellence in teaching and research in mathematics at the undergraduate and the postgraduate or the graduate levels, right? So both the graduate and the undergraduate levels, right? Our mission to deliver the high quality undergraduate, graduate and professional programs in mathematics and produce graduate and postgraduate who can think critically and mathematically. So that is basically our vision and mission. So when we actually think about our history, so actually the Department of Mathematics history goes to 1921, right? 1921. Basically the Faculty of Science celebrating the 100 years, and as well as the Mathematics Department also same. So we are also celebrating the 100 years. So the Department of Mathematics has been playing an integral part of the Sri Lankan university system from 1921. And until the 1967, when the University of Colombo was formed, the Department of Mathematics, our department actually cater both science and the art faculties. But now, of course, mainly we focus only Faculty of Science. So the very important point is like this mathematics honors classes. Earlier we call actually the special degrees. So we started those programs in 1922, right? So you can see like that now we have like a huge 100 years history. Now the other point is now that you can see that now this slide, the mathematics department building, right? I'm sure like that now you have seen it like because when you see any kind of like a TV program or any kind of things now, this is actually the symbol for not only Department of Mathematics, not only for the Faculty of Science, not only for the University of Colombo. This is a symbol for Sri Lankan higher education system, right? So when it comes to like a mathematics, I think you need to know about like that the mathematics is like both an art and science. Also, it provides the necessary and the essential tools for any kind of like a subject area, right? Not only science, right? Maybe economics, maybe engineering, finance, medicine, biology, any area. And also, when we think about the mathematics, so generally we talk about the pure mathematics and applied mathematics, right? So the pure mathematics, actually, it's the heart of the core area of the human thought, right? So which of course provide and also train you like critical thinking and logical manner, logical behavior. So wherever the applied mathematics provide sort of the mathematical application in the various areas. So when it comes to the what mathematics department provides, so we provide, you can see like the various kind of like a program, as usual, undergraduate degree programs, and also the postgraduate degree programs, and the research-based programs, also the external degrees, right, distance education, and also some of the services, right? So maybe I will, a little bit later I will come to the undergraduate degree program, but in this time I will actually try to cover the other areas. When it comes to the postgraduate degree program, so the Department of Mathematics is offering, presently we are offering the two MScs. One is the MSc in Mathematics Education, and also the other one is MSc in Financial Mathematics. Both degree programs are well defined and actually the highly demandable courses in the Sri Lankan university system. And also the Department of Mathematics provide in the research-based degrees, MPhil, Master of Philosophy, and also the PhDs. Not only that, the Department of Mathematics, of course, offering distance mode learning system also. We support under external degree BSc in Financial Engineering, right? Not only that, of course, now the Department of Mathematics, of course, providing the services to the entire Sri Lankan community, providing like a mathematics Olympiad. I think the more information will be provided by the respective coordinators. But I think that it's my duty actually talk about a little bit more of the undergraduate degree program. I think now, I know like that now you are actually connected, I mean the two students group, of course, connecting with us. One is a physical science students, the other one is industrial mathematics and mathematical finance students. So let me first talk about the physical science students, right? So the physical science students, for the physical science students, Department of Mathematics offering basically in the level 1 and level 2. So we are offering the two subjects. One is a pure mathematics, and generally the pure mathematics, we can talk about a little bit of analysis, complex analysis, functional analysis, algebra, and the various kind of theoretical subject areas comes under pure mathematics. Then also we offer applied mathematics, which of course count the classical applied mathematics as well as the modern applied mathematics and also the applied analytics also. So when and also like under this new curriculum revision, of course now that we have started the last with the last intake, so the applied mathematics we are now offering the practical courses also, right? So I think you can of course experience new ideas and the new concepts and how we use actually the mathematical concept in a practical manner. So when you think about this is actually basically the level 1 and level 2. So I think now we need to actually think about a little bit of like that, how it process, right? The physical science students, of course, the applied mathematics is compulsory for all of you. So, but the pure mathematics is you need to choose it, right? It's, but if you choose like both applied mathematics and the pure mathematics, right? Basically the applied mathematics with the pure mathematics with other subject. So you can actually proceed to the two, basically the two honors degree program. One is a mathematics honors, and which I think Dr. Dharmasena will provide you the more information about that course. And the other one is applied mathematics honors. So that also the Dr. Anuradha Singh will provide you more information about it, right? So if you actually, if you actually don't choose pure mathematics, right? So still you can actually proceed to the another option. One is a computational mathematics honors, So that, of course, Dr. Anuradha Maha again will talk about that degree program also, right? So basically what I want to say that now, particularly if you are actually interested about to follow the mathematics, either mathematics honors or applied mathematics honors, you need to definitely take the pure mathematics as a subject, right? But I mean, if you take pure mathematics or not take, it doesn't matter, right? You can still go with the computational mathematics honors degree, right? Also, the Department of Mathematics is offering another honors degree program, which is we call actually the professional degree or industrial oriented degree program, which is the name is Finance and Insurance honors degree. So the more details will be actually delivered by the Mr. Hamim, coordinator. So this is for basically the physical science students, right? So let me actually talk about the industrial mathematics and mathematical finance students. So these students, right, this intake, level 1 and level 2, again we are offering pure mathematics as a subject and as well as the applied mathematics as a subject, right? As I mentioned earlier, so the pure mathematics, so under the pure mathematics, this level 1 and level 2, we cover analysis and also the algebra and also the linear algebra courses, right? So similarly, we are offering, of course, applied mathematics, but you can see that now in addition to this classical applied mathematics and the modern applied mathematics, we of course mainly focus two key areas. One is financial mathematics and actuarial mathematics. Those are actually the two key areas. Of course, specifically, we are offering only for this industrial mathematics and industrial statistics and mathematical finance degree program. So when you think about also like in this degree program also now under the new curriculum revision, so the last time we started, of course you can also enjoy with this applied mathematics practical courses, right? Practical courses. So then when you think about this industrial mathematics and mathematical finance, so what is actually what kind of like honors degree programs offered under the industrial mathematics and mathematical finance. So one particular program which is a mathematical finance honors degree, right? So this degree program mainly talk about the finance industry, insurance industry, and especially actuarial mathematics or actuarial science areas, right? So which is actually the highly demandable area, right? But and also I just want to mention about that not only this degree, also we are actually giving you the chances, right? Giving you the opportunity to follow the mathematics honors degree as well as the computational mathematics honors degree, right? So you can still, of course, have a chances or opportunities to move with the mathematics honors as well as the computational mathematics honors. So not only that, of course, still you can, of course, enroll with the finance and insurance honors degree, which is comes under industrial oriented or professional degree program. So those are the actually things like that we are offering Department of Mathematics for both intake, physical science, as well as industrial statistics and mathematical finance intake. So unfortunately this time due to this COVID-19, so we are actually addressing and then we are of course delivering this orientation program in the distance mode, but however in the near future, so you may visit to the Faculty of Science and then you can, I think like that you can identify like that the Department of Mathematics now located in the two places. One is this historical building. I'm sure like that you have seen it. The other one is like that the industrial statistics and mathematical lab building, right? So we are actually keeping, locating in the two places, right? These are some of the facilities the Department of Mathematics is offering. So I know like that unfortunately you may not of course get these opportunities quickly, but however, so during the semester time, we hope like that you will of course get, you can of course get these opportunities, right? So we are of course offering the computer laboratories and also the library facilities, right? So the computer laboratories, as I mentioned about that, now both intake, so we are offering applied mathematics courses, practical courses, so you can actually use these facilities if you have actually chosen such a things, right? Now this is actually our strength, right? So let me actually introduce our staff members. I think the first one, I think you can see like myself, and the next one is Professor Chula Jayawardena. He is actually the expert in discrete mathematics and the graph theory area. And the next one is Dr. Romain Jayawardena. She is actually particularly in the category theory. It comes under algebra. And then the Mr. Hamim, he is of course analysis and as well as the mathematical economics also. Then the Dr. S.K. Borulugoda is of course specialized in the non-smooth analysis, so which is basically the pure mathematics area. Then the Dr. Qna Session, he is analysis as well as the mathematics education experts. Then Dr. Jagat Vijayaratna, he is coming from computational mathematics and also the quantitative finance. Then Dr. Tilan Hevage, he is mathematical economics. And then Dr. Jayama Mendy, she is basically from algebra. And Dr. Dharmasena, he's also he's basically coming from complex analysis. And then Mrs. Lakshmi Edirisurya, she's applied mathematics, and Dr. Maha Singh, Dr. Anuradha Maha Singh, mathematical modeling, and also quantum computing, and the Dr. Erangda, specialized in the partial differential equation. Dr. Dilruk Galage, also the specialized in the partial differential equation, and Ms. Lilanti Samarasekara, analysis coming from the analysis. Also now at the moment, 3 of our staff members actually on study leave, right? And then we of course get services from the industry people who are expertise in the various industry oriented and also the applied mathematics, some of the applied mathematics areas. Let me actually little bit actually discuss about what kind of like research. So research we are now doing, but these are actually the brief ideas. I hope like that if you visit to our web page, you will get the more information. At the moment, of course, we are my staff members, my team, of course, engaging in the various kind of like a research, diversify areas, analysis, algebra, graph theory, and also the discrete mathematics, mathematics education. Also the applied research, especially in the mathematical modeling in biology, medicine, and the infectious disease, quantum computing, computational modeling, quantitative finance. So you can see that there's diversify areas, right? So maybe if you want, actually you can of course send some of the inquiries and also the questions. Also you can visit to our web page for more information. Also our department of course having the 15 card position for the junior lecturers. So we are having another like that is we call academic supportive staff, and also the 3 non-academic staff, and also the 1 programmer who is of course supporting the lab management and as well as these practical courses. So I hope like that I try to provide the brief introduction about the Department of Mathematics and as well as the courses which we are offering and as well as our strength. And respective coordinators, so they will of course provide you the more details during this time. And let me actually, on behalf of the Department of Mathematics, I wish you all the best. And I'm sure like that now, so that this next 3 years or 4 years, so you are with us and then try to utilize all the resources which we are having, human resources and as well as the physical resources, and get the maximum benefit. And then finally, I wish you all the best, and as well as like that the end of the 3 years or the 4 years, actually try to become the meaningful and the productive person, and then you can definitely serve to the Mother Sri Lanka. Thank you so much. And now I would like to actually invite Dr. Qna Vijayaratna to talk about the mathematics. Thank you.
Thank you, Professor Sanjeeva. Ibon Vanakkam. Good afternoon to everybody. So I'm going to talk a little bit about mathematics, and my title is Why Mathematics? Now the question is a little bit open-ended question. If you look at the other question, how many Sri Lankans have won the Fields Medal? So that is actually not, it has a definite answer, not like why mathematics. In case you're wondering what this Fields Medal is, it's not a medal given to the best paddy field cultivator or anything like that, nothing to do with those greener fields. So it's actually a medal awarded to the best mathematician or mathematicians every 4 years, and it is named after the mathematician who actually initiated and funded it. His last name is Fields. So I'll give an answer to this question at the end of my presentation. Now we could a little bit more get the question more clarified. We could ask why mathematics is essential, or why mathematics is the queen of sciences, or why does mathematics develop thinking more than the other subjects. Now, you have done combined mathematics for your A-level, and up to A-level you did mathematics, right? And suddenly you had this new subject called combined mathematics. Actually, that subject is only, it is in Sri Lanka, only in Sri Lanka, not in other countries in the world. I did not do combined mathematics, so a long time ago it was 2 subjects, pure mathematics and applied mathematics, and then when it came to 3 subjects, it was actually, the 2 became combined mathematics, and the combined mathematics has a pure mathematics component and an applied mathematics component. Now, as Professor Sanju also mentioned that mathematics is both an art and a science. Now, why is mathematics an art? And why is it a science? So I think it's very easy to see that it is a science because it is used in science everywhere, right? So without mathematics, it's hard to think that you can do any science, right? Even in physics at A-level, you saw that the mathematics was substantial, and even in chemistry, right? Maybe you didn't see that in biology, right? Anyway, we don't have, I think, any student who did biology here. So why is it an art? Usually, the mathematicians, they build structures, very beautiful ones, and they analyze things very deeply. So naturally, they look at the beauty of these structures. So it is an art, especially in pure mathematics, because in pure mathematics, it is done without any explicit or immediate consideration of direct applications. So just the inspiration may come from the physical world, right? But when the pure mathematicians do mathematics, it's actually they do it by looking at only the essentials, and they take it forward, and they build structures upon structures. And you could say that applied mathematics is the application of mathematical methods whose roots are in pure mathematics. So that's a little bit about the nature of mathematics. Now, when you think of mathematics, it is actually, someone has said that it is unreasonably useful in applications. There are unreasonably good applications of mathematics. And here I have listed some. Now, all the words in red are actually pure mathematics areas. So number theory is at the heart of cryptography. And you can't think of today's world without cryptography. Internet and any financial transaction, so you need cryptography. And also group theory, another pure mathematics subject. It has a lot of applications in physics, chemistry, and cryptography, and so is complex analysis. Lots of applications in hydrodynamics, thermodynamics, and quantum mechanics, and even in topology, which if you get selected, if you do well the pure and applied in the first 2 years and get selected to mathematics honors program, then you will have the opportunity to learn topology. And it also has, even though it looks very abstract, it also has applications in computer science, computer graphics, data mining, and robotics, and all those fields. So, so as you can see, it is unreasonably applied, has applications in sciences. Now, before answering this question, why mathematics, let's look at this question, what is mathematics? So, at A level, you studied combined mathematics with, which has the two components, pure mathematics and applied mathematics. Now, let me take this example, functions. So, you studied functions, and I think all of them were given by formulas, right? But if you take a function like this, it is 0 for rational numbers in this closed unit interval between 0 and 1, and it takes 1 if it is irrational. You know rationals and irrationals, right? Rationals are numbers which can be expressed as fractions of whole numbers, right? A over B, where A and B are integers, and other numbers are irrational numbers, right? So, can you think of, can you visualize the graph of this function? You will have difficulty to visualize if you visualize it the way you are used to, right? Maybe you are used to visualize mathematics, objects in mathematics by maybe in the same physical world, that in your mind, right? So with that kind of visualization, you won't be able to visualize this. But still, you know, we can visualize, so you have to change your visualization, right? You can even integrate, but not the integration you learned at A level, not according to that integration, but you will learn different integrations. For example, this can be integrated by Lebesgue integration, and that you will learn if you get selected to mathematics special. Okay? Now, this kind of mathematics, where we have these mathematical objects which are not given primarily by formulas, but they are carriers of conceptual properties. So we have to pay attention to the concepts. We have to understand them well. And even proving is not just following some rules and getting at the result, which most often you did at A level, right? But this is actually a process that involves logic and deductive thinking. So we have to deduce our results using concepts. So we should know what our axioms are, and so we have to know the logical process, the proving method, the methods of proofs, right? So it takes actually a different picture, different form at the university. For example, if I talk about my experience, in my first year I did physics, pure and applied, and for me physics was not different from what I studied at A level, but pure was very different because it actually had a different, altogether different form. Because first we had to learn logic, and then we had to be well aware of the axioms that we use, and we had to be, when we prove things, very careful only to assume the axioms, right? So it was a very different experience, and actually I really enjoyed it. So I think it goes for about chemistry also, that I don't think that there will be a big difference between chemistry you learned. Of course, you will have to learn more knowledge, but not in the, I don't think there'll be a difference in the form. Now, language, the mathematics has its own language, because the natural language is not precise enough to do the mathematics. So we have, the mathematics has its own language using quantifiers and other symbols and very precise logic. And for this reason, maybe that the father of Galileo, father of science, Galileo Galilei, said that mathematics is a language with which God has written the universe. So you have to believe it, right, when Galileo Galilei said that. Now, when you do mathematics, especially at the university, it is important that you look at your own cognition and see whether you really understand the concept. Now, in mathematics education, there are two terms on understanding. One is instrumental understanding, which actually basically, you know the rules and procedures, and you know how to compute things, but you can't tell exactly why they work, right? For example, if I take one from A level, right? So you know how to integrate, but you have no idea what you get, what this integration is, right? How you get this formula. You know, you find the antiderivative and you plug in the upper limit and the lower limit and you subtract. You have no idea why, you know, it is related to this anti-differentiation, right? And relational understanding is actually, you know what to do, the rules and the procedures, but you can also explain why. So when you do mathematics at the university, you should try to get a relational understanding, because with instrumental understanding, you won't go that far and the learning will be boring, right? So this will be actually different, I think, at A level. Maybe most of you went through the drills. You know, you solved a certain problem type, you know, many times, right? And maybe you were more on the instrumental understanding, not relational understanding. Now here's a personality that we should know, Richard R. Kemp. He was a pioneer in mathematics education. So he wrote a very good book, this called the Psychology of Learning Mathematics. So this shows that when learning mathematics, we have to think about the psychology, you know, because this is a human being learning mathematics, not a robot, right? So we should be able to, we should actually look at our own cognition, metacognition. Now let's look at, you know, this problem where we have these two functions. One is a parabola, other one is the function 1 over x. So their graphs are given, and so you know about the continuity. You had some idea about continuity. So continuity means that, as the word suggests, that something continues without a break, without a gap. So if the graph can be drawn without lifting the pencil, maybe that function is continuous, right? Now, when it comes to learning mathematics at the university, right, you will have lots of definitions. So the definitions introduces concepts, and you should know these definitions well, and you should be able to apply the definitions and other results accurately, right? So here's a definition of continuity. So if the limit of the function as extend to any point in the domain, then the function is continuous at that point. If it is equal to the functional value, right? So this is one way of, you know, defining the continuity of a function at a point. Well, now with that, if we look at the second function, that 1 over x, right? So in the domain, the 0 is not there, right? But if you look at any other point, so any point in the domain, the function, the limit of the function at that point is equal to the value of the function at the point. So actually, that function is continuous, right? But if you look at this Chomsky's book on advanced calculus, they have given this rule on finding the continuity of a function. It says that in constructing a graph of a continuous function, the pencil need never leave the paper, while for a discontinuous function, this is not true, since there is generally a jump taking place. This is, of course, merely a characteristic property and not a definition of continuity or discontinuity. So according to this rule, actually, that second function, 1 over x, is not continuous, right? But that is not true. So this actually shows you that even reading these books, you have to read with an open mind. You have to think about what you read, not accept as they are, right? So now understanding these concepts, now the concepts are introduced by definitions, right? We have these two constructs which actually can help us in understanding things, a concept definition and concept image, right? Now the concept definition actually is a definition that defines a concept, right? So it actually is given in form of words. And the concept image actually what you understand, what is in your mind, that how you understand the definition, how you interpret it. So it says that the total cognitive structure that is associated with the concept. So you have to be mindful about your concept images of the concepts. Now here's some information about the guy who came up with these two theoretical constructs. He was an algebraic topologist, and later he studied cognitive psychology under Richard Kemp. So he actually says this, that I think is very important. The human brain is not a purely logical entity because it's very complex. The complex manner in which it functions is often at variance with the logic of mathematics. So sometimes maybe often it's illogical. It is not always pure logic which gives us insight, nor is it chance that causes us to make mistakes. Of course, the insight, we know, logic can give insight, but we get insight in lots of other ways. And also, the mistake that we do, not by mistake, sometimes, maybe often, right? Here I have some example. I don't know whether I have time. I have to check the time I started. So till I get the time, I'll actually continue. So this actually, on the concept image, concept definition of this series, you had done series at A level, right? This is an alternating series. So it's 1, -1, 1, -1, right? Likewise, and then the mathematicians were they were struggling to understand this series and its convergence, because at that time they did not have a clear definition of convergence, right? So, so one mathematician argued that gone. Okay, so so one mathematician argued that it is actually the sum of the series is half. Now, by your A-level knowledge, you should know that this series actually does not converge, because if you look at the n partial sums of this series, right, they alternate, right? The first one is 1, and the sum of the first 2 terms is 0, and the sum of the first 3 terms is 1. Likewise, it alternates, right? So it is not a series that is convergent, but some mathematicians at the time thought that this is convergent, and it actually converges to 1/2. So it took a while actually for them to come up with the right definition, right? This shows that if you look at the history of the evolution of the concepts, it's actually very colorful to say the least, but it gives us a lot of insights on how these even in we can get a deep understanding of the concepts now by if you look at the history. So I'm going to skip these slides because I don't have a lot of time. So learning mathematics, when you're at the university, you will experience that it has 2 phases. One is actually this the experimental side. That you may not experience that much, but if you pay attention to what you do and what you prove and what you solve, you will see that most often it is not what you write. What you write is totally different from what you do. So those are the 2 phases. How you think about a problem, solution of a problem, or a proof is very different from what you write, right? Now, to study this kind of mathematics, you should have the right mindset because, as I said earlier, it is different from the combined mathematics, the mathematics at the university, pure mathematics and applied mathematics. So what is the right mindset? Well, you should have the mindset that that is progressive, that you look at every experience as an opportunity to develop, as an opportunity to learn. So if you don't think that your success is dependent on your what you were born with, then I think you can actually learn the subject well and you can go far, because we have seen from our experience that the students actually who were not defined by A-level results or other things, right, they did well. Who actually took their experiences as the opportunities to learn, they did well. In fact, there is research to back our observations. Carol Dweck is a Stanford a psychologist. She did research and she found these 2 kinds of mindset: growth mindset and fixed mindset. You can Google this and learn more about it, and it is worth knowing this. So as I said, don't let A-level define your abilities, right? This actually we are talking about from our experience, right? So learn from your mistakes and take every mistake as experience. It's an opportunity to learn. Also, you have to be passionate about what you do. And as I said, relational understanding is very important when you study mathematics at the university. But then you might find it easier to memorize these procedures, algorithms, right? But the thing is that when you get out of this place and go for higher studies or go for a job in the industry or in the private sector, you will find that they want people who can think, not just who knows algorithms. So here we have a saying. So the saying goes like this: if you give a man a fish, you can keep him alive for a day, but if you teach him how to fish, he can keep himself alive indefinitely. So metaphorically, if you compare this to hunger as problem solving, right? So giving a fish to somebody hungry, so that means you teach somebody to solve a particular problem, right? Then he will solve that problem, right? But if you teach him how to fish, how to solve problems in general, how to think about how to think out a problem, then he can always solve problems. the same slide. Okay. Here's something good thing about our students. Somebody who has done quite well. Uddanali Kadukampala, and if you Google him, you'll find that he has this subfield named after him, fraction operators. So that is something we can be happy, right? So before I answer this question, I want actually, okay, let's go to the slide. So why mathematics? I think you have got lots of answers to that, right? And to the second question, how many Sri Lankans have the Fields Medal? Well, it's a big zero. So maybe you can change it. Now to change it, you have to shoot for the moon, aim high, right? Even if you miss it, you will land among the stars. So that means that there's nothing wrong with aiming high. Even if you miss, you'll be among the stars. That means, there will be a lot of good that come out of, that aiming and making an effort to reach that aim. So I'm going to end my talk here. Thank you very much. I'm going to invite Dr. Dayal Dharmasena to talk about the Mathematics Honours Degree Program. Thank you.
So, good afternoon, everyone. So, I am Dayal Dharmasena. I am the coordinator of the Mathematics Honours Degree Program. So, I am going to do a brief presentation about this Mathematics Honours Degree Program. So, our Mathematics Honours classes at the University of Colombo started in 1922. That means, our faculty is celebrating 100 years, and next year our Mathematics Honours Degree Program is going to celebrate 100 years. Right? So this is a brief description about our program. So the main goal of our program is to provide a deep and broad understanding of mathematics itself by mainly focusing on understanding mathematical structures, patterns, and conceptual relationships that underlies mathematics. And the core of the degree program consists of three main fields. They are called algebra, analysis, and topology geometry. So these three main fields, they are traditionally considered as main areas of pure mathematics, right? So our core consists of these main areas of pure mathematics. So in addition to that, it is complemented with optional pure mathematics and applied mathematics courses, and also it consists of a research project in the 4th year. Now, if you are interested in exploring new things, so that will be a good opportunity to you. Right, so I should talk about the selection criteria. So before the selection, I have to talk about the eligibility, right? So now the first requirement is you have to follow both pure mathematics and applied mathematics in 1st and 2nd year. So in level 1 and level 2, you have to be in a combination which consists of pure mathematics. So those three combinations are P3, P5 and P6. So the first requirement is you have to be in one of those subject combinations. And then you have to take all the applied mathematics core courses and pure mathematics core courses and maintain a GPA of 3 in each subject. And when it comes to the selection, we select you on the based on total weighted marks obtained for pure mathematics core courses in level 1 and level 2. Right? So from physical science stream, so if you come from these 3 subject combinations, then we are going to take 10 students from that. Now last year we opened up this mathematics honors degree program for students in industrial statistics and mathematical finance stream. Now we know that we have met so many students from the industrial statistics and mathematical finance stream, so they didn't know how this mathematics is interesting, so they applied for the industrial statistics and mathematical finance stream, and after they came to the university, they realized that they like mathematics more than anything else. So we have had requests from so many students like that. So because of that, we decided to make this program open also for industrial statistics and mathematical finance students, right? So we can take maximum 5 students from this stream, and this is the eligibility requirement. So you have to maintain a minimum GPA of 3.30 for level 1 and level 2 pure mathematics core courses offered to this stream. So that means you take 4 pure mathematics core courses in level 1 and level 2. So for those 4 courses, you have to maintain a GPA of 3.30. And also, you take financial mathematics courses, right? For those courses, you have to maintain a GPA of 3.0. And once again, the selection criteria is based on total weighted marks obtained for those pure mathematics core courses. Right? So I plan to talk so many things, but since the time is running fast, I will skip few things. So this is something you should remember. So mathematics, it is not about numbers, equations, computations or algorithms. It is about understanding. So you will realize this more if you take pure mathematics as a subject in level 1 and level 2. Also there were few things I wanted to discuss, but since the time is running fast, I will not go to those things. Now, anyway, Dr. Chanak Vijayaratne talked about some interesting things. So our graduates, so they usually do well and they easily find opportunities for higher studies, mainly in US and also in other universities, in everywhere else in the world. Right, I think that should be enough. Now, if you want to contact me, this is my email address. So if you have any questions, you can send me an email. And now I invite Dr. Anuradha Maha Singh to talk about applied mathematics and computational mathematics honors degree programs.
Hello, good afternoon. So I think you had a very nice introduction to the mathematics degree program. So that was all about mathematics, right? So I'm going to talk about applying the mathematics. I'm talking about applying mathematics. That's actually, we are applying those rigorous concepts that you learn in pure mathematics to the real world. So it's, when I say applied mathematics, I think once you start following the lectures at the university, your attitude on applied mathematics or this division in mathematics as pure and applied is going to be radically changed. Because at the university, actually, when we say mathematics, or particularly pure mathematics, it's about something rigorous, something really abstract. But in applied mathematics, actually, we are relating it to the real world. So both components, both aspects are very important. And I'm talking about the applied mathematics, and basically the applied mathematics programs we are offering to you. In the sense of applying mathematics, we have 2 degree programs designed particularly for you. Actually, applied mathematics, with the name applied mathematics and the name computational mathematics. I would say these are recently introduced degree programs, because actually you will be the second batch to undertake these degree programs, right? So the first batch would be your seniors, and you will be the second batch to undertake these programs. Earlier, we were offering, and still actually we offer these programs, BSc Honours Degree in Finance, Business and Computational Mathematics. You can see, as indicated by the name, it's about finance, business and computational mathematics. And also there had been another degree program called Mathematics Statistics with Computer Science. Now these 2 are replaced by 2 new programs, one on applied mathematics, particularly designed for applied mathematics, on applying mathematics, intended for higher studies in applied mathematics and also for the industry. And the other one is more industry-oriented, more application-oriented, that's the BSc Honours Degree Program in Computational Mathematics. So these previous 2 programs, so they have been replaced by the 2 new degree programs. Let me say a word about this BSc degree program, Honours Degree Program in Applied Mathematics. You may already have some idea what applied mathematics is, okay? Now actually there are 2 pathways. Either you may be willing to join the academia. Maybe you want to pursue your higher studies in applied mathematics or something related to that, maybe on theoretical physics, maybe on theoretical computer science, maybe on statistics, I don't know. So if you want to do higher studies related to some discipline on applied mathematics is engaged, actually then this will be a very good opportunity, and we did not have the opportunity before because those degree programs were defined about a decade ago, about 10 years ago, right? At that time, you know that pure mathematics is somewhat well established, somewhat little conventional. On the other hand, when it comes to real world applications of mathematics, we have to be up to date always, right? So considering the demands, considering the needs, and also considering the opportunities and requirements in the industry, as well as, I mean, different industries, maybe insurance industry, or maybe the data sciences, maybe recent developments in those fields, right? So we have considered those things and we have introduced this applied mathematics program. So there are 2 pathways, as I mentioned earlier. You may join the industry or you may join the academia as well. So we have considered those facts and we have done a major revision of our courses. And so this one is one of the results, one of the consequences of those revisions, that you are fortunate and well, you are welcome to follow this program. But anyway, you need pure mathematics. You need pure mathematics to follow this degree program, as you can see from the selection criteria. So it's actually about your GPA for applied mathematics core courses together with AM 1.12. I think these things will be available in your handbook also. And GPA 3.30 for pure mathematics courses as well. Now, when thinking of these combinations, I would like to ask a question from you. Why is applied mathematics compulsory? I mean, if you are from either physical science stream or even from the industrial mathematics stream, definitely you are engaging with us, right? I don't think any other department can claim this. So certainly you are engaging with us. Why is it? What's the reason behind this compulsory engagement? The reason is applied mathematics is essential. If you are going to be graduated, if you are going to get graduated from mathematical sciences or physical sciences, whatever discipline, the first 2 years, yeah, you have to follow applied mathematics. So mathematics has lots of applications. So these programs, specifically these programs are about applying mathematics, and there are lots of applications in the industry as well. Okay, so pure mathematics is also very important. If you want to follow this program on applied mathematics, then you have to follow pure mathematics. You have to take, you have to think of a combination which includes pure mathematics as well. And well, these are the courses we offer in level 3. You can see it's a combination of mathematical methods, discrete mathematics, optimization courses, and there are some recently introduced courses consisting of some statistics topics as well. So we have designed the syllabus We have considered a lot. We have many discussions and many arguments as well. And finally, so you have very nice syllabus after many years, particularly designed degree program for applied mathematics with two pathways. One door is open actually to the industry, and the other door is open to the academia, right? And some level 4 courses. So here also you will see some very recent advancements in applied mathematics. As I mentioned earlier, applied mathematics is essential in a sense that maybe in the guise of some other subjects, maybe in the guise of machine learning, maybe in the guise of data science, maybe in the guise of different fancy names, but what you have inside those things will be applied mathematics, right? Mathematical thinking is inevitable if you want to solve an industrial problem also, right? So the program is particularly designed by considering this fact. And now here's the other degree program, and I'm the coordinator for this one. This is called the BSc Honours Degree Program in Computational Mathematics. This one is particularly designed by considering the demands in the industry. So if your intention is actually to join the industry later, after graduating, if you want to join the industry, this would be ideal for you. As you can see, the curriculum is designed, as this slide reads, to provide hands-on experience in solving industry-related problems. So there are some very nice mathematical problems and very hard mathematical problems also, right? In the industries, with an uncompromising share of theoretical knowledge. So we do not compromise on theory, but still we are more focused on applying them inside laboratories, and there will be some practical courses as well, and essential industrial training component. This is very important. So this degree program on computational mathematics is particularly designed. If you are willing to go to the industry, this would be the ideal degree program, and there will be lots of practical sessions. You will spend lots of hours inside computer laboratories. You will have real problems, okay, and you will be solving them. In addition to that, there is this essential training component where you will go to some industrial place, and of course you will be talking to people. You are not solving problems just inside laboratories, no. You will be at those workplaces. So you will have your first ever experience in the industry. You will talk to these people, and they will explain the problems to you. They won't express these in terms of mathematical language, no. They will say these things in your own language. So you may have to model them, and you may have to solve them using computers, and you will find solutions to them. And this is how the world, the world has come to the state it is these days, right? So you will have this essential industrial training component, which will be really a good advantage, and it will be highlighted in your CV wherever you apply. And we do not rule out the possibility of applying for higher studies even if you follow the computational math degree program. Although its primary intention is actually to cater to the industry, right? The major goal is joining the industry, yes, but it equally caters to the academic demands as well. If you wish to learn mathematics further, computational mathematics further, still you have the opportunity, even if you follow the computational mathematics program. And pure mathematics is not a requirement for this course. If you want to get enrolled in this degree program, PM is not a requirement. It's open to everybody, right? As long as you are following applied mathematics courses and your marks satisfy the eligibility criterion, you are welcome to follow this program. As you can see from the slide, the eligibility is GPA 3.30 for the AM courses. And it's actually for the physical science students. And you can see this syllabus. If you go through these topics, I think the handbook will be available to you. If not, you already have it in your possession, right? So then actually you can go through these topics and you will realize that, okay, this degree program is particularly designed to cater to the industrial demands. There are lots of new topics, very much related to computer science. As you can see, computational methods and scientific computing, theory of computation, discrete applied mathematics. So this discrete mathematics and theoretical computer science and algorithms, so those things are actually the things you need to solve industrial problems. As I said, the worldview of an applied mathematician is this. There are real problems, and you build models. And these models actually, these models consist of equations. Okay? These models, they consist of equations. And these equations, you have to solve them. So you will solve these equations and you will find solutions, and ultimately you will be applying these solutions to the real problems, and you will be solving real problems. Therefore, computers are inevitable there, right? So definitely you have to be well versed in computer science as well. So we have particularly included some computational mathematics courses where you will be solving problems using computers. So you'll spend many hours inside laboratories. Not only that, you'll be inside many hours at those workplaces as well. And you will get a first-hand experience to the industrial problem solving. Well, that's about these courses, and yeah, that's all I have to say. And I cordially invite Mr. Hamim to talk to you about the industrial and I think the insurance degree program. Sir, the mic is yours. Thanks.
Good afternoon, everyone. This is about the industry-oriented honors degree program in insurance and finance offered by the Department of Mathematics. So this is an industry-oriented program. So just to specify that it is a professional degree program. So the reason why it is introduced about 3 years ago is our finance and insurance industry needs personnel with good mathematical skills. So what we decided about 3 years ago is to introduce this program so that those who employ in that, who get employment in that industry will have good mathematical background and they will perform well in that. Also, this degree program has another advantage. Also, those who want to proceed with postgraduate studies can also do, because it has a research component which has to be done towards the end. So about the program summary, so we select 20 students at the end of the second year, so on merit. So and in the third year and in the first semester of the fourth year, so they are taught the finance and insurance courses along with related mathematics and statistics courses. So that will be done in the third year and also in the first semester of the fourth year. So in the second semester of the fourth year, that is the last semester of the degree program, they'll have to do a 6-month internship in a firm, in an insurance or a finance firm under the supervision of an industry mentor. So at the end of the internship, they should write a report about their internship and present it in the university. So also during this time, that is during that internship, they must do research, they must work on a research problem of the industry which will be given by the industry mentor, and they must submit the research report at the end of the semester and present it also in the university. So then about this program, so this was introduced about 3 years ago and 2 batches have completed and all have got employment in the insurance and finance degree, and most of them secured employment in the same place where they were doing the internship. So that's a huge advantage, where students were not waiting soon after their degree, they all got employment. So we should say the program was very successful. If I just compare the last 2 years results and the students getting employment. So that is all I have to say about this program, it being very different from all the other programs where the concentration is mostly on the industry and also the job market. So thank you. If there are any questions which you all have, you can start asking from now on.
Well, it's time to move to the Q&A session. First question they ask, what are the opportunities for ISMF general degree?
So I think the question is basically the opportunities are basically the opportunities on ISN MF degree. General degree, I think now you are referring about the 3-year degrees, right? So the 3-year degrees also industrial statistics and mathematical finance. You are of course learning statistics, mathematics, finance and also the actuarial. So you will get the opportunity to join industries such as insurance, finance, banking sector and the corporate sector.
Are there any recommended elective courses to be followed by students who are willing to do a maths special and move on for a PhD in maths?
So I will actually refer to this question to Dr. Qna Session.
What is the question again?
Are there any recommended elective courses to be followed by students who are willing to do a maths special and move on for a PhD in maths?
Elective courses.
Recommended elective courses to be followed.
Yeah, so to first of all, to do math special, one has to study pure mathematics. So I think this is the mathematics honors degree program, right? Yeah, and there are actually few optional courses in the first 2 years. So one is the history as motivation for mathematics. And then there are optional applied mathematics courses. You want to go? Vector calculus and what else? Yeah, vector calculus and computational mathematics. So those are in the first year. Second year, yeah. So those can be taken as optional courses. And of course, one can actually take these MOOC courses, which are offered by some of the best universities in the world, massive open online courses. So that's also an option. I know that lots of students who have gone for graduate studies, they have taken these courses. So that's also another way.
Next question will be, will there be access to the syllabi of the courses?
Sorry?
Will there be an access to the syllabi of the courses?
The question is not clear for me.
They asked, will there be access to the syllabus of the courses?
Access. Yes. Of course. Once you, of course, register, so usually I hope like that you get the idea about like that the LMS and all these things, right? So now once the the academic activities start, you will be getting LMS access and then you can enroll with the course. So you can get the lecture notes and also now in online materials, right? And as well as the quizzes and the various activities, various academic activities you can of course experience.
Can you please tell more about computational mathematics and history as motivation for mathematics?
So I'll refer to Dr. Anuradha Maha.
Well, I will talk about computational mathematics, and then I'll refer to Dr. Chanakya as for the history of mathematics. I think for computational, if the question is it about the degree program on computational mathematics or the courses on computational mathematics? Courses. Okay, so most of the courses on computational mathematics are actually conducted inside laboratories, computer laboratories. So in these courses, you will get a real problem, and you may have to model the real problem using some mathematical concepts and notions, and then it will be a mathematical problem afterwards. But solving the problem will not be done manually. Instead, it will be done with the aid of a computer. So there are some standard computerization software like MATLAB, Mathematica, or even some packages are available in Python as well. So you will get your experience in these packages, these mathematical tools, and then you will be solving the problems, and you will be finding the solutions to the real problems, and finally, you will interpret those solutions. Because you had a real problem, not a mathematical problem. Then you will be, you will be converting the problems into the language of mathematics, and you'll be solving them with the aid of a computer, and eventually you will be translating that back to the language of the real world. So that's what we are going to do inside those computer laboratories. That's basically about the computational mathematics courses. And I think about the history as a motivation for mathematics, Dr. Chanak is the best person to talk about.
Thank you, Dr. Anuradha. So, history as motivation of mathematics. Now, there we learn how the concepts evolved through the history. Not about, this is not about the history on the mathematicians or the civilizations in that carried out, these the developments. For example, we look at how the Babylonians came up with the solution to the quadratic equation. When they did not have any notion of negative numbers and how to use an unknown, no equations, so they solved it using cut and paste geometry. And even so, that was actually about 1800 years before BC, 1800 BC. And if you look at even the cubic equation, how it was solved in the 1500s without the algebra that we know now, without symbols. They used a little bit of symbols, but not much. And even then, for example, Cardano's solution to the cubic equation, he used again geometry. So when you look at how they solve this with without all the tools that we have today, it actually is one thing is very fascinating, and the other thing is that it provides us insights to what we do today, and we get better understanding. For example, now I talked about the Fields Medal, and I think the Manjul Bhargava, he won the Fields Medal maybe a few years ago. He's from India, and he said that he was inspired by some of the things that he learned from his grandfather, because his grandfather taught him the mathematics used in old Sanskrit textbooks. So he was inspired by those. So I think learning history can be a big motivation for to do mathematics. So I'll be so I teach. So I taught last year, and maybe I'll teach it this year also. So I use the book titled "The Journey Through Genius." It's a very nice written book, and so the idea is actually to look at the history of these, the evolution of these concepts, and learn mathematics. So to actually have better insights into mathematics that we do today. So so I think it will be a big help if you are going to, if somebody is actually interested in doing higher studies in mathematics, especially even applied mathematics, computational mathematics doesn't matter. Thank you.
If we manage to get industrial statistics honors degree, what kind of jobs we will get?
It's not actually the industrial mathematics honors degree, it's mathematical finance honors degree. So the mathematical finance honors degree, which is of course a research-oriented degree program, but however, we are catering to the both academia and the industry. So if you are actually interested to do this mathematical finance degree, of course now you can do you can of course proceed with the higher studies and then enter into the academia, and as well as you can actually enter into industry, finance industry, and which is mainly in this degree program. We are covering up actuarial, professional exam syllabus also, and also if you look at that, the chartered financial analysis, CFA, syllabus. So we are somehow covering those things. So you will get additional opportunities also to do such a kind of like a professional exams, right? So I think, I of course now refer to the Dr. Jagat Vijayaratne, so he can add few more things.
Yeah, mainly when you do mathematical finance, you can do quantitative finance. Actually, it gives also that in the good foundation in mathematics initially in first 2 years, and this helps to actually in financial sector is not like some years back, not like accounting and bookkeeping today. So the top people, those who are the fund management and are mostly the graduates from the physical sciences, and most of them are actually PhD holders or actually at least higher postgraduate qualifications. So there are a lot of opportunities there in insurance industry, banking, and in almost in fund management area.
How should we select our subjects as an ISMF student for our future special degrees?
So the question is referred to the IS students only. IS students, if I am correct, they don't have any options. So basically now the Department of Mathematics and the Department of Statistics providing the courses. So according to my knowledge, they have to take all these courses, level 1 and level 2. Right? There are no more options for them.
If I want to do IT related jobs, what subject combination should I choose?
So yeah, the student actually they want to do IT related courses. Basically now there are plenty of opportunities providing the Faculty of Science, right? One area is like that now, as Dr. Anuradha mentioned about that the computational mathematics, and also the physics is offering the computational physics. So and also the chemistry is also offering the computational chemistry, and also the faculty is offering IT and management, right? So all these opportunities are available. So there are no any specific kind of like a courses need to be taken, because computer science courses for the physical science students, even in the industrial mathematics, industrial statistics and mathematical finance students, for you, level 1 and level 2 computer science courses is compulsory. Actually you are taking, right? All of you are taking. So there is no any particular kind of thing. So if you are actually planning to move in the computational mathematics, you can take the applied mathematics courses. If you are planning to go with the other subject area, you have to choose like that particular subject.
If I want to go through the IT field, is that suitable to select pure maths? And is pure maths as same as we studied in A-level?
I think I will refer to Dr. Qna Vijayaratne.
Well, I think the first part is that whether IT, what is that?
Person wants to do IT. Is it? What the question is like that? If we select the pure mathematics.
Yes. Yeah. Definitely, mathematics is actually quite helpful in doing IT, because one is that you learn to think well. You develop your thinking, right? And also the mathematics you need in IT. So if you do pure mathematics, that is well supported, right? So answer is a definite yes. And the other part, what is the other part? Oh, no, I told you that it is not the same, because in many ways it is not the same. For example, I actually talked about my experience in learning physics in my first year here and the maths. So it's very different, because you learn the real mathematics here. So as I said, that the concepts are deeper. You need to understand them well. As Dr. Dharmasena said, that I think Thurston's quotation from Thurston, William Thurston, he was also a Fields medalist. So it's actually mostly on understanding. So this process of working with axioms and the logical process of proving, which is very finer than you experience at A-levels. So, and also the material. For example, you will not do lots of things that you did at A-level. The applied mathematics part, you will not do here. And also the pure mathematics part, you will learn lots of new mathematics. Very fascinating mathematics. So short answer is no, it's not different. And the long answer is actually, you will learn a much fuller, much richer, much beautiful pure mathematics. Thank you.
Can I add something? Because we seem to receive questions on IT, and my research field is actually on computational mathematics, particularly quantum computing, some recent advancement in computer science. My comment is actually the word IT is broad, and it's too broad. Okay? So let me confine myself to computer science. Is it okay if I replace it by computer science? When it comes to computer science, it has a very specific meaning, because even web designing can be called IT, right? But when it comes to computer science, theoretical computer science is same as applied mathematics, and a kind of rigorous form of applied mathematics. And there are lots of applied mathematics, other applied mathematics topics taught in computer schools, computer science schools. So as for the mathematics you need to understand computer science, I can definitely say discrete mathematics is essential. So we have introduced a lot of new discrete math courses and a lot of new optimization courses also. As Dr. Chanakya said, pure mathematics is, it's definitely it's helpful. In addition, now we are offering lots of courses where real computer science. Okay, computer science in the sense, computer science with a very strong emphasis on mathematics is taught. Thanks.
Since our time is limited, I'll go to this last question. Doing pure math be a benefit for a chemistry special degree?
Yeah, I think maybe I will answer, because now actually the pure mathematics is I think, I believe like that is the heart of the thinking, right? Thinking and then logical manner. Actually, I would like to add the few things of the previous question also. Now the question was whether it's good to do the pure mathematics for IT, because normally in the IT and computer science, all kind of like a field, you need logical thinking. You need like a logical thinking, and then if you don't have that kind of like a thinking, so that's the problem, right? Normally like that, this IT field is a product development, right? So when you want to develop the product, you have to find out whether it's existence or uniqueness and all kind of like properties. But all these properties, of course, coming from pure mathematics. Even the chemistry also the same, right? So if you learn anything with the pure mathematics, I am sure you can become a giant. Is that correct, sir? Right.
Yeah, that is true. If you study pure mathematics, then you can be the best chemist in the world. And if you study physics with pure mathematics, you could be the best theoretical physicist in the world. What do you say, Dr. Damsena?
Yes, that's true, and I also agree with that. So if you do anything with pure mathematics, you can be the best in that field. Right? So I think that answer should be sufficient, right?
Here we came to the end of our session. Thank you.
Thank you.
All right, so good evening to all of you. So my task is to introduce you to the enhancement courses that are offered by the Faculty of Science. As you know, there are three main domains of domains that you need to cover in your undergraduate degree. The first one is knowledge, the second one is skills, the third one is attitudes. So danuma, kusalata saha akalpa. All three have to be developed when you step out of this place as a successful undergraduate. So the knowledge domain is covered by the courses that are offered from the different departments when you enter the faculty, and also the skills in your practical sessions. But some of these skills and attitudes have to be developed in some other ways which are not captured in the traditional courses that we offer in the faculty. So because of that, we have introduced some of these enhancement courses for you to capture those skills and attitudes. So these would not come under any of the departments, and I'm sure you have all gone through the handbook that was given to you, that is online. Go through the handbook and you will find these courses as easy courses, right? These are open equally to all the students, and also you need to remember they are compulsory for all of you to get your degree. Compulsory meaning you have to complete at least 4 credits by the time you graduate from here. Otherwise, you will not be conferred with your degree. Right? So believe me, although it says only 4 credits, we always find a student or two at the end who have not completed their degree requirement just by not doing an easy course. All right, so once you do these are offered from different places. One of the key areas that are covered, that's covered in this through the easy courses, it's career and personal development, right? So most of these courses are offered from the career guidance unit of the Faculty of Science, and you will get to meet these leading private and industrial company professionals, and you will get to reflect on your skills and attitudes and find out which career path you want to develop in your future. And then there are other aspects that are covered through sports, language skills, entrepreneurship, and then some of these extracurricular activities like photography, right? And believe me, as I told you earlier, easy does not mean easy. You need to get these credits, and otherwise you will not be conferred with your degree. You need to keep this in mind, because students often we find they will forget to register for these courses, and at the end they will come and try to claim for these credits, which is not allowed in the Faculty of Science. So when you register at the beginning, you need to register for these courses and continue in that semester. All right, so if you look at the courses that are offered, you will see the language skills are covered by the courses EC 1001, and then the EC 2001 in your second year, and also EC 3001 in your third year. Now, as I told you earlier, you need to do at least 4 credits. That does not limit you to do more credits of all these. So you need to identify what are the things that you need to develop inside you throughout these years, and pick these courses that would develop those within these 3 years before you graduate, right? And then from the career guidance unit, you will get a glimpse of this tomorrow also. You have these courses like career and personal development 1, 2, and 3 throughout the 3 years, and some of these courses would make you think about your career opportunities and the career paths that you would like to take in your future. And then EC 2020 enterprise, entrepreneurship, and innovations is also an area that we focus heavily from the Faculty of Science. And that course is custom made to guide you through to become an entrepreneur in your future, or else to take that career path forward. You need to make note of this factor. Who are the coordinators of these courses? All the academic staff in the Faculty of Science would voluntarily coordinate these courses, and this is the list of courses and the coordinators that are there to help you out in selecting and continuing these courses. Right? And then I will talk a little bit about the sports credits, because I'm pretty sure most of you have done some sort of a sport in your school days, and you would like to continue that when you come to the faculty. And the sports credits are offered as enhancement credits. So if you look at your handbook, you will find the Faculty of Science offers 23 sports credits. Sports are offered at the Faculty of Science, and students can participate in one or many as you can handle during the 3 or 4 years you are here, right? So these sports credit would, courses would span from badminton to track and field to whoever is really good in carom, you have a course for that also, right? And throughout the years, first, second, third, and the fourth years, you can register for these courses. And Dr. Anushka Vikramasuriya will be the coordinator of these sports credits, so you can get more information from her in the times to come. As you can see, we offer a whole range of sports, except for this particular sport, of course, sadly. But we will see in the future, we would get some of you to develop that in the Faculty of Science. All right, so we offer a whole range of sports from track and field to carom, and then this would give you one single credit per course. So how would you get that credit is a thing that you need to know. So you can participate in all these events that are organized inter-university, inter-faculty, and to support you, there is a well-equipped gymnasium at the Faculty of Science. Once this COVID situation is gone, you can always come in and freely use that facility. All right, so per academic year, you can get minimum of 1 credit per academic year. And if you want to get more, you're free to do that also. And this is monitored by the Director of Physical Education, right? So all the information that you need will come from Director of Physical Education. He will also address you in the due course, right? So these are the criteria to gather your sports credits. The honors, if you want to get you will be qualified to get an honors pass for this. If you represent Sri Lanka in a national tournament, or obtaining first, second, or third place in an individual event, or being awarded university colors. So, so this is not just going in and playing in the evening. You need to achieve something in your particular area of sport, right? Forget about the 1 credit, but you will all play this sport to achieve something, right? Right, so then a merit would be when you represent the University of Colombo in an event, or obtaining first or second or third place in an inter-faculty tournament. And satisfactory would be representing the Faculty of Science in an inter-faculty tournament and obtaining first, second, or third place, right? So the information you can get about these from the director or the coordinators, and also Department of Physical Education. Right? All right, so how do you register for these? You need to register for these in the same way that you register for your other credits, right? So in the beginning of the semester, you need to register for your sports credits. If you forget to register for that within that drop period, you cannot claim them at the end of the semester, right? All right, so once you have achieved something out of your sport activity, you need to file that at the Department of Physical Education, and they will route that certificate to us. Then we will add that credit to your transcript. All right? So as you know, you have all done your English exam. Now you will be placed in your respective English course, and then you will be completing that with an exam at the end. Once you complete that, you will actually get 3 credits out of that, right? 3 credits, that means it's just 1 credit that you need to earn from all these courses for you to graduate, right? That's a minimum requirement for graduation. But what I would urge you to do is actually to take this as an opportunity to do more easy credits and get those skills and attitudes developed for in you, right? So, all right, so it's just 4 credits, as I told you earlier, and some of these are prerequisites for internship programs, so you need to very carefully go through your handbook. We call it like a Bible. You need to have it in your hand for a while until you understand what is actually in it, right? And then, so read through these lines carefully, because if you miss something, you can't claim for any of these later on in your degree program. All right? I'm emphasizing this again and again. You need to get only 4 credits, but if you don't get it, you won't graduate. I'm telling you repeatedly because we do see students missing these out. All right? So what I will do is I will hand over to the CS coordinator, Computer Sciences course coordinator, Mr. Anjana Bandara. He will talk about the CS courses also, and then the coordinator from the UCSC side will also talk about them, and finally we will take some questions from you. The panel of coordinators are here today with me, so you can ask any question from them. They will be ready to answer you. So any general questions, you can guide them to me, right? Either by phone or by email. I will be ready to answer those. All right? Anjana. Okay, slide deck.
Hello, everybody. I think you all are a bit tired now, right? By listening plenty of explanations and various other stuff from the beginning of the day, right? But I will not take that much of time to explain about the CS courses. I will explain most important features of these CS courses, and I will hand over this place to the CS coordinator from the UCSC side to explain about the course details and how important these courses are. Right, so I am actually the CS course coordinator from the Faculty of Science side. Right, so actually these CS courses are mainly offered by the UCSC. You know what the UCSC is? UCSC is the University of Colombo School of Computing. It is one of the leading teaching university, right, institute. There are plenty of professional lecturers, and it is a well-recognized school attached with the University of Colombo. So these CS courses are actually offered by the UCSC. When you talk about the CS courses, actually CS courses are flowing from your first level, that means from your first year to the end of the fourth year, right, level 4. So at the various stage the different types of programs are arranged, and I would like to talk about the most important features of these CS courses and how the CS courses are important and for what these courses are important. Now, when you talk about the CS courses, when you look at the handbook, right, you will see plenty of courses are listed in your handbook, right? Now, for an example, when I take the physical science course list, so you can see in your level 1 course list, you can see physical PH courses are there, CH courses are there, AM courses are there, STs are there, PMs are there, and you can see CS 1102 and 1101 courses are listed under the level 1 course of physical science, and some more courses as well. Now, likewise, when I move to the level 2 courses of the physical science, again there are 2 courses are listed. And when I move to the bioscience course list, right, you can see again there are 2 courses are listed. Actually, when you when you compare the physical science courses and the bioscience courses, right, both courses are the same. Now here, under the bioscience, CS 1102 is one of the first semester course, that is the only first semester course, and CS 1101 is the second semester course offered for the physical science as well as the bioscience. So similarly, when you go through the level 2 courses of the bioscience, the same courses are offered for the physical science as well under the level 2. So mainly there are 2 level 1 courses offered for the Faculty of Science by the UCSC, as well as 2 CS courses offered for the Faculty of Science by the UCSC. Right, so I'm not going to talk in detail about these courses. The CS coordinator from the UCSC side will talk about the content in brief, right, how these courses are developed and what is the link between these courses, right? But now I think you already know that you can select some of these courses, right? Now these CS courses are marked as core courses by marking this with a cross, right? You can see that. So those are core courses. But you can still select the core course, one of these core courses, or any of the core courses, right, according to your preference, right? And now when you talk about the physical science degree programs, right, you should select all core courses, right, from at least 3 main streams. Now, for an example, when you talk about the streams, right, the physics stream is one of the streams, right? Chemistry is another one. Applied math is another one. Likewise, right? So you should select all core courses of at least 3 main such streams. Now here, I think you may already know about these things. Now, when you, if you want to select, if you want to eligible for a special degree or the honors degree, right, program, right, all the honors degree programs are listed under either physics department or the chemistry subject stream or mathematics stream, or let's say statistics stream from the physical science side, or from the biological science side, plant science or zoology, right? So those are the key areas which are the all special degree programs or the honors degree programs are offered by. So when you look at that, right, you cannot see the CS stream offered any special degree program or an honors degree program for the science students, right? So that is true, right? The CS courses or the CS stream won't offer any of the honors degree programs, but the CS are actually acting as supporting role for other honors degree programs, right? So from that point of view, right, if you are going to pick one of the honors degree program, right, so you should be very careful. For some honors degree programs, some CS courses are compulsory. So without those CS courses, you cannot go for those honors degree programs. So you can still select the CS courses. Either you can pick CS course or you can avoid CS course to continue your studies. But if you, let's say, if you drop some CS courses from level 1 and level 2 of your degree program, right, you cannot eligible for some sort of honors degree program. So you must be very, very careful from that point. So I would like to show you what are the honors degree programs which are mainly targeting the CS courses. Now when you go through your handbook from page number 23 to onwards, right, you can see the requirements for the honors degree programs, right? It starts from biochemistry and molecular biology. Now when you look at that program, you cannot see any CS programs are listed. So CS programs are not needed, right, to follow the biochemistry and molecular biology. Likewise for the chemistry as well. But when you go for the computational chemistry, you can see, right, you need to get a minimum C grade each for CS 1101 and 2002 course, right? So that is a requirement to follow the computational chemistry. So if you are going to, if you are targeting the computational chemistry honors degree program, right, you must take this CS 1101 and CS 2002 courses. So likewise, I will show you another one, right? That is the next one is computational physics. So it says you need to get GPA 3 for CS core courses. Now when you look at the CS core courses of your level 1 and level 2 course list, right? CS 1102, CS 1101 and CS 2001 and CS 2002 are the core courses, CS core courses. So you should take all 4 of those core courses, right, if you are going to, if you are targeting the computational physics honors degree program, right, and you need to achieve a GPA 3 for those CS core courses. Right, so let's move for another one, that is statistics with computer science. Again, here also you need to maintain GPA 3.7. It's a little bit higher than the previous one. GPA 3.7 for CS core courses, right? All CS core courses which are given under level 1 and level 2. Right, so that is another CS requirement for a honors degree program. The program name is Statistics with Computer Science. And let's see, there's another one. Okay, yes, bioinformatics. So for that honors degree program, you need to get GPA 3 for CS 1101, CS 1102 and CS 2001 courses. So these are the main 4 honors degree programs that you need to consider, or you need to take the CS core courses to get eligible for the honors degree program. Right. So that's what I mainly want to tell you. Right. Now from this point onwards, I will hand over this place to the CS course coordinator from the UCSC side, Dr. Manjushree. Could you please come here and explain about the courses, the content of the courses, and how important these courses for their future career. Over to you, Manju.
Hello. So as Mr. Anjana mentioned, like computer science courses offered by UCSC is basically helping you to progress your career, as well as a supportive structure for your degree when it comes to the specializations that is offered by the science faculty. So if I introduce you to computer science, so when the time, if you take about 10 years ago, we might say computing was just constrained to just a computer and maybe taking a printout and typing a report and so on. But as sciences has evolved over a period of time, what has happened is you can do any type of science, whether it's plant science, zoology, chemistry, physics, statistics. Somewhere down the line, you will have to take computer sciences seriously, as well as modeling of computer-based models pretty seriously. So for you to do that at your later years, you need to start somewhere. So that somewhere is basically what the science faculty is offering with the 4 courses mentioned in the program. So I'll just go through the first 4 courses of the first 2 years, and then I'll give you a very brief introduction what is offered in the 3rd and 4th year. Once you come there, you will be able to have a better understanding of what to select. Can I have the... Okay, so if you go to the first year courses, Okay, so generally, computing department UCSC offers science faculty 4 courses in first 2 years. That is CS 1002, that is Introduction to Computing, CS 1101, Fundamentals of Programming, CS 2001, Internet Technologies, and CS 2002, Fundamentals of Software Engineering. So we start with CS 1002, that is Introduction to Computing. So that generally tells us what this field is about, its applicability, very, very basics of computer science, like how computers are represented, how data is kept, and what is the formats, and what are the things with relevant to hardware, software, and bit of history of how things has got to place it is today. And from that, of having a basic understanding of computers, we move to the other subject, which is the fundamentals of programming. So now you move from having a somewhat of a overall understanding of how it works to get to the level of making a computer work for you. So basically, doing programming is enables you to get your things done the way you want. So when you try to do physics or statistics, you might have to come up with models which you cannot actually do in real world data. You might have to write your own computer model and simulate it. So for that, you need some sort of programming. So we start with programming in the first year itself. So these 2 courses, for any specialization with respect to the computational streams, you need to have a minimum C grade to move forward in that special stream. And then we come to the second year, When it comes to internet technologies, we talk about how the modern day internet is made up of and how you can leverage the technologies you have in the modern day internet to get your work done, and how to come up with state-of-the-art websites and things like that. That will be really helpful for you to market your stuff as well in the future if you come up with inventions and so on. And lastly, the mandatory course of the first 2 years is software engineering. So you know how computers work, you know what programming does, and then you have to have an understanding of how to make software work. So that will tell you how to put things together and come up with a working software in CS 2002. So subsequent to these 4 courses, which are offered as mandatory courses, you have a set of other courses, I think, which we did not touch upon, but I'll briefly tell. That is CS 3001, which is rapid application development. So that means that course is basically about how to get your applications running quickly and how to come up with very quick software. And then we come to more core courses like data structures and algorithms. That is about more theoretical side of computer science and so on. So these courses combined with other courses such as machine learning, data analytics, parallel computing, and database management are offered as courses that is optional for the streams. So based on your taste, or based on your liking, you can pick these courses. These will be offered by UCSC for the science faculty as well as our students. So you will get to mingle with the UCSC students as well in the latter part of your degree. If you have any questions, I'll be happy to answer them. So I'll end this session with respect to the computing course and hand it over to the lecturer.
Here we came to the end of our orientation program, and I hope all of you enjoyed well. And thank you, dear teachers, and my beloved juniors.